So welcome to the KubeVirt intro. This is a bird of a feather session. My name is Scott Collier, and I work for Red Hat, and I focus on the upstream KubeVirt community. However, I do have some history with Seattle. I did live here for about 5 to 6 years, 20 years ago. Met my wife here. My daughter was born here, and I was actually stationed 30 minutes south of here at Fort Lewis in Washington. However, I haven't been back here since 2000, so this is kind of refreshing to get this weather again. Now I'm based out of Austin, Texas. So, Daniel?
Hi, my name's Daniel. I work as a cloud infrastructure developer at SAP, and my team basically develops and maintains the OpenStack infrastructure for the SAP Cloud Platform, which is mainly used for our Cloud Foundry and Kubernetes-based workloads. And I don't really have a history with Seattle.
Very good. So this is a bird of a feather session. We would like for it to be interactive. One thing that I do want to do is introduce some of the contributors that I'm aware of in the room. So up front here, we've kind of got a little gathering with Joe Callan, who works on support. We've got Adam, who works on the storage subsystem for KubeVirt. Ryan, who works on operators and making sure that we can install cleanly. Steve Reichart, working on support, and David Bossel, who focuses on core virtualization for KubeVirt. Mike Henriksen, working on operators and installs, and Josh Burke is in the back, who helps us with the community side. So welcome, everyone. So just as our morning exercise, how many folks here have deployed KubeVirt in some shape or form? Wow. Okay, so this is an intro. Hopefully by the end of this, what you'll walk away with is a better sense of how to get started and take it back and kick the tires on it, do a proof of concept on it. Now, another hand raising, how many people have existing virtualization like infrastructures on premise? That's what I thought. This is the perfect session for you. Okay. So what we've got here is the story so far. We're really looking at like the intersection of managing virtual machines as well as application containers in the same umbrella, right? So we want to make sure that we have a platform that provides a consistent experience no matter where the workload resides. With application containers, we can leverage, the past 5 or so years, of knowledge that we've gained. And with virtualization, we've got like a history that spans back even further to the past, 10 to 15 years, perhaps for some of us, with LibVirt. And what we've got with Kubernetes is we basically need a couple of infrastructure providers to provide us virtual machines. We've got OpenStack, AWS, Qbert, we've got our public cloud providers like AWS, GCP, even Azure. We provision Kubernetes on those, and it gives us this kind of consistent platform and kind of satisfies that abstraction for the open hybrid cloud that we need. We can grab virtual machines and provision Kube on top of that. So what we have now is we have our application containers that we need to manage with Kubernetes, and then we have some use cases where we just need like stricter isolation for some of these virtual machines. So for example, on the slide, you see some examples like Kata containers or gvisor from Google or isolates from Cloudflare. And then we've got Firecracker that was just announced by AWS a couple of weeks ago at reInvent. Now these provide like stricter isolation kind of runtimes for your applications. It's a little bit different of a problem space than what we're looking at. What we're looking at is KubeVirt for basically managing and virtualizing existing workloads. So for the containerizing infrastructure that we have, we've got application containers that are coupled with Kubernetes orchestration. That's basically becoming the new standard for our applications, right? And we've got some workloads that, we can lift and shift straight into containers, but this isn't always the case, and there's a few reasons for that. We have technical reasons and we have business reasons, right? So for the business reason, we have like the cost of basically decomposing these monolithic applications that are running in virtual machines into microservices and managing those with Kubernetes. And we also have time to market. Like, that takes a long time to do that. Some of these applications weren't designed to run this way. And some of the technical reasons may be, you know, we have the need to leverage an operating system that's not Linux. Maybe we're using Windows or something like that we want to keep it virtualized for. Maybe we have the need for a custom kernel for whatever reason. So we can't share that same host system with other applications that have their own requirements. So because of that, there are definitely legitimate reasons to keep your applications virtualized in VMs. So the other thing that we're looking at is like a bare metal resurgence. So some customers want to basically alleviate any overhead that hypervisor may introduce. And some customers have the need to, you know, access certain types of hardware like GPUs or SRIOV devices. That may be another reason to go with bare metal. And then as the mix changes and we have, you know, customers who have a need to deploy their new applications on top of as kind of containerized microservices, they've got their, you know, legacy existing virtual machines that are running in their environment. We need to basically provide a platform for them to have that consistent management experience. So what is KubeVirt? Just kind of in a nutshell, KubeVirt enables it enables Kubernetes to manage virtual machines in a common shared environment with your application containers. That's what it is. We can leverage the knowledge that we built out with KVM over the years and take that user space that represents a virtual machine and basically wrap that into a container and manage it with Kubernetes, right? So one of the use cases that a developer may have is they've got a unified, you know, they need a unified platform to build and deploy applications on, regardless of whether or not they reside in applications or containers or virtual machines. And then, you know, KubeVirt also represents basically the Kubernetes community's commitment to the future of application orchestration and the common fabric across the open hybrid cloud. So it enables us to combine those existing virtualization workloads onto the same platform if they're running in virtual machines. Once you get them on the same platform, you're at least buying yourself some time. So once you're managed, you know, both application containers and virtual machines under that same kind of umbrella, you can at that point start looking at how best to decompose your application out of that virtual machine, manage it with Kubernetes, and have that same existing kind of experience from an operations perspective for sure. So for a few more details, notice on the top we've got KubeVirt.io listed. That website has documentation for the project. It has examples to get you started. And it has lots of blog posts that the engineers and contributors in this room have been adding over the past year. So please do go check that out. So KubeVirt is basically, it's a drop-in on top of your existing Kubernetes cluster, right? It's an extension to your kube cluster by CRD, the custom resource definition. And CRDs basically in Kubernetes allow you to extend the Kubernetes API in a pluggable way to add new functionality. And that's what KubeVirt brings to your cluster, okay? It leverages a native approach, meaning that once the API is extended, you can use the same tools that you're familiar with to manage your other kube resources and objects the same way. So it also leverages the existing objects that you're familiar with, like the storage subsystem with CSI and also CNI for your networking subsystem. So a few of the components that we have here, we've got KubeVirt, which is the virtual machine, you know, operator. We've got CDI, which is basically provides a way to import images from various formats into Kubernetes PVs. So CDI is more or less, it's like, could be considered its own independent project, which kind of spins at different cycles than KubeVirt, but they do provide a feature and functionality that we leverage. It supports ingesting different types of file formats into Kubernetes PVs. The ones that we're generally going to interface with the most are like QCOW2 or RAW type images. Ingest those into PVs and then boot your VMs to access those. And then we also have like CSI and Ember listed there. And that basically provides a way to support the current like storage drivers from the Cinder project. And then we've got V2V, which allows you to import virtual machines from an existing platform, okay? Like VMware, for instance. If you need to start migrating those over to Qbert, that can be one of the things that you look at. So, an OpenShift UI, I'll talk about that a bit more once Daniel gets past his use case, but we basically have a UI with some extensions that allow you to manage and monitor your virtual machines when they've been deployed on an OpenShift cluster. We've got virtctl. This is a tool that's basically an add-on to the infrastructure that allows you to do things like start VMs, stop VMs, connect to the VMs via serial console or VNC, perhaps. So just kind of in a nutshell, this is what Qbert is. And at this point, I'm going to hand it over to Daniel to talk a little bit about his infrastructure here, his use case.
Our use case. So to understand our use case, I have to set the context here a bit. So I guess most of you have heard of SAP. We are a quite large software company focused on the enterprise market. Actually, the largest software company in Europe. And of course, since basically all the other software companies, we are currently heavily looking into Kubernetes, building it into most of our new products and so on. And because of that, we have a very large developer community is currently looking to get Kubernetes clusters. And because of that, we have the need to actually manage this large fleet of clusters. But we are not only having development cases here. Something like this is also more and more production use cases coming on here. And so to do that, SAP started our own open source project to do that, called Project Gardener, which we use to manage, to create, delete, upgrade, scale clusters. And I won't talk about Project Gardener here now. If you're interested, you can go to our booth or look at it at GitHub. I want to talk about Qbert here. But what you need to understand is that because we have that in place, we have a very dynamic use case. And because of that, we need a really stable infrastructure to work on. Exactly. And so now to look into our own data center here, which is what my team is working on. So right now in our production, we basically have OpenStack used as an infrastructure layer. And we use that as a cloud provider as well for Gardener and also for the clusters that Gardener manages. This means that Gardener uses the machine API to talk to OpenStack, to manage the nodes, and also that it uses the Cloud Controller Manager for OpenStack to build up load balancers, to expose services, to initialize nodes, and so on. And this works okay. But what we see is that OpenStack is actually a quite big and complex technology stack. But we'll show you on the next slide what I mean by that exactly. But the thing is that it is pretty hard to maintain. And as I mentioned earlier, we need a stable infrastructure and hard to maintain and stable infrastructure that's not going so well. And the other thing is that the requirements and operational knowledge are quite high. So you need to operate Kubernetes, which is hard. Then you need to operate OpenStack, which is hard. And if you put that together, it's not getting any easier. And the next thing is that if you're talking about edge case deployments, so we have customers who want to do like small deployments. And if you have this big and complex OpenStack control plane, that does not really work in that context. If you have just a few servers, it's difficult to put OpenStack in there. Yeah, so let's have a look at what I mean by a complex stack. So you don't need to understand that, but if you Google for OpenStack architecture, that picture is literally like the first thing that you find on Google. I even cut out some of the stuff like Horizon, the Web UI, and so on. But what you see here are basically the core components of Kubernetes with all their API services, agents, plugins, databases, AMQP queues, and so on. And basically, if any single one of these components here doesn't function correctly, you get stability issues on top of it. So let's just say as an example, the message queue for Neutron doesn't really work. Then you get problems in your network plumbing, and then you have Gardener trying to provision clusters or upgrade clusters, I don't know, basically creating nodes. And the creation of the nodes itself works in OpenStack, but the network plumbing doesn't work. And so your clusters or your nodes never really come online. And because everything is automated, Garden and Kubernetes will try again to create new nodes, and but nothing's coming online. And therefore you get high stability issues here. So we were thinking about what can we do to solve this issue, to simplify this stack. And our first idea was to just take out all the dynamic features here, just to do a static bare metal deployment of Kubernetes, but our developers were quite clear here. This doesn't work, so they need this dynamic API to create clusters, to upgrade them, and so on. And so static deployment was out of question here. And the next idea that we had was, well, we like the idea of having Kubernetes at the infrastructure level. Why not provision Kubernetes clusters on top of it? And so at first we were having some problems there because on the one hand, the container isolation is not as good that you could use it to do real multi-tenant deployments on there. And the other thing is that it's actually quite hard to run the kubelet inside containers. But yeah, then we came across KubeVirt, and we had the idea, why not use KubeVirt VMs to provision our nodes, and then use Gardener to use these KubeVirt VMs to create clusters on top. And so what this does for us, it simplifies the stack. You don't need all this OpenStack control plane here. You basically just have your Kubernetes control plane, which is much simpler than OpenStack. Also, the amount of operational knowledge that you need is reduced because you don't need any knowledge about the OpenStack components. You basically have Kubernetes all the way down. And lastly, doing like edge computing cases with this setup is much easier because your control plane is just so lightweight. So in our lab, we actually have single node deployments with multiple clusters on them. And, I mean, of course, that's just lab deployments. You won't get any high availability out of them, but it's possible. And so if you have edge case deployments with like 3 to 5 servers, this setup works there. And I mean, we are not quite there yet. The Garden integration is not yet finished, for example. Also, we are currently investigating how to do proper network isolation between the different clusters. So, I mean, we have the VM boundaries to encapsulate the nodes, but we still need to think about how to encapsulate the networks. But there's much work currently going on in KubeVirt to enable this, or device plugins and so on, to get like custom network devices into the VMs and so on. And what we also already did was developing a cloud controller for KubeVirt so that we can properly initialize nodes and also expose services over load balancers. And yeah, that's our current state here. So we do not have this in production yet, but we are currently developing this, and it looks pretty good so far. Yeah, and I guess we could continue with the demo.
Good, thanks. Okay, so just quickly on the Red Hat use case, we've got Red Hat does have a product called CNV, which is Container Native Virtualization, which runs on top of OpenShift, which is basically our enterprise release of Kubernetes. And it's got kind of a developer-friendly spin to it with the web console that you can use to manage your virtual machines, as well as the storage integration being backed by Gluster and some of the other capabilities there. So I think this is kind of what a lot of you are waiting for. I wasn't nervous before, now I am. This is live demo time, so we'll see. I'm going to mirror my display, and hopefully this will show up properly. Okay, you can see it. I can see it. That way I don't have to turn my head too much. All right, so this is a demo that all of you can do. It's a very low barrier to entry. You just need your laptop. I'm just using Minikube to do this. And we'll talk about some other ways that you can get your hands on it in a bit. So the first thing that I want to do, I'm going to kind of like copy and paste over here so that I don't mess up anything typing it. I'm just going to set my version to 0.11, which is the latest one, and then just kind of take a look at my Kube environment. So kubectl get nodes shows me that I've got a working kind of Kubernetes cluster. I can get my CRDs, which don't exist yet, and I can also get all of my pods. Oh. Okay, so we can see here that this is a basic kube install, and now what I'm going to do is just provision KubeVirt on top of this. So this, everybody in here, you take your existing Kubernetes cluster, you can do the same things, and all I'm going to do is apply this KubeVirt YAML file, and it's going to install it just in a couple of seconds, right? So that's done. It's installed. Now I'm just going to check again for the CRDs that got added. You can see here that we've got our virtual machine instance migrations, presets, replica sets, virtual machine instances, and then virtual machines that were added. So now the Kube API has been extended. I can take a look at my pods. And you can see here that they are in the process of being provisioned. Now, I am on the event Wi-Fi network, so I'm not exactly sure how long it'll take, but it shouldn't take too long. Let's just watch that for a second. And in the meantime, while those containers are creating, let's take a look here. Can everybody see that okay? Okay, let's just take a look at that KubeVirt YAML file that got created. So we can take a look at different custom resource definitions in here that got created. I think there are 5, maybe, I think there's 5 of them. So here's the custom resource definition that got created for the VM instances, for the machine instance replica sets, and then presets, and then finally the virtual machine instances and the migrations. So that got created, and let's take a look over here. Looks like our containers are starting now. That's good. Let's just get our namespaces, our pods one more time. Everything's up and running. So now KubeVirt is provisioned. We've got our CRDs, we've got our pods. I'm just going to make this a little bit smaller. And now what I want to do is deploy a virtual machine. So bring this to the top of the screen. We're just going to grab this version of the vm.yaml based off of the GitHub repo, and you can see that the test VM was created. So now we've got this new object that's being presented to you in Kubernetes, right? So let's do a kubectl get VMs. This wasn't there before. Now we've got a test VM that was created. The VM isn't started yet, but it's there. So let's go ahead and now take a look at the vm.yaml file that we actually imported. So you can see here that this is based off of the KubeVirt API that was extended. It's a kind virtual machine, and it was named test VM. So again, like when I was talking earlier, these are like tools that you're all familiar with, the same kind of YAML that you're used to configuring and creating to deploy virtual machines. One thing here is that the spec is set to running false, which means it doesn't start when the object gets created. And you can also see that we've got like the ability to configure different attributes for the virtual machine. So this is kind of a trivial example that we're using on a local laptop. But again, if you go to kubevirt.io, take a look at the documentation, you can see some of the other attributes that you can add. But here we've got a container disk, we've got network interfaces, we've got the amount of memory that this VM is going to consume. we can take a look at the networks that it's going to connect to, and by default, it's the pod network. And we'll be able to demonstrate that it actually got an IP address off of that once we boot up. And this is the image that's actually getting booted here. Okay? So the next thing that we can do is that tool that I had mentioned before, virtctl. Well, with that, I can start the VM, and it scheduled it to start. So before I did the kubectl get VMs, now I can do a kubectl get VMIs and take a look at the VM instance. And it says that the test VM was created. Now I can also go back and take a look at, I can describe that VM and make sure that the state changed from running false to running true. Get VMs, I can then describe VM, test VM. And if we scroll up here just a little bit, we can actually see that that state did indeed pivot to true. Okay? So now that that's been created and started, let's also take a look at kubectl at the namespaces again, and we can see that the Virt launcher pod has been created, and the container is creating right now. I can run a describe against that. And I can see that it's pulling the image right now. So it's been scheduled to a node, in this case, the only node in the cluster. And it's pulling down the image. So what I'm waiting for is, if I can try to connect to it now. But I'll go ahead and try. So like virtctl console test VM. And you can see here, the VM's not quite booted up yet, so we'll just have to give that another second. Yeah, as long as this is in this state, it'll take just a second here. So let's let that create, and it shouldn't take too long. It's just basically a matter of it pulling it down over the event Wi-Fi. Sometimes it takes a minute, sometimes it takes a little longer. But while we're waiting here, do we have any questions while this is kind of booting up from anyone in the audience? Lots of hands. You, sir? I'm sorry, could you repeat that? No, and then I'll repeat it. So the question was, where do you store the image and specify how it's stored? Adam, do you want to take a...
Yeah. Let's see. So we basically have a couple of different ways that you can get an image from where you have it to your virtual machine. For this demo, we're using a container disk, which is an ephemeral image that's pulled from a registry, and it starts as part of the Virt launcher pod and then becomes available to the virtual machine to use. So that would be an ephemeral, just like a normal container image. But if you want something that's persistent, you can actually have a persistent volume claim that's associated with your virtual machine. And then Scott mentioned CDI, which is a way that actually will pull a QCOW2 image or a raw image from wherever you have it on a web server or other location into the PVC so that you can start. And in that particular mode, it would start over and over persistently like you would expect.
Thanks, Adam.
So we started off using just the file. Oh yeah, so the question is are we using block mode or file mode PVs? So when we first started the design, the only thing that was really available was file mode. So that's how it works today. We actually just store the disk image as a single file on the persistent volume on the file system, but we're also working to add raw block volume support as well. So I think it's actually working in KubeVirt today.
Okay, just really quickly, the demo has about 2 more minutes, so let me wrap that up and then we'll transition over into Q&A. So the virtual machine has been launched now, so now we can actually connect to the console. And this is the test VM login. So we've connected to it, log in with Cirrus, and go, Cubs, go. And now we're logged in here. So now I can take a look at the IP address. You can see that we did get an IP address from that default pod network that we were presenting before. Okay, I'll disconnect from that. And the next thing that we can do, it's like typical operations. We're just going to stop the VM. And then we can also use kubectl to delete the VM. And if we want to clean up our environment completely, we can just do a kubectl delete -f KubeVirt, and that wipes our environment clean so that we can start over. So that concludes the demo. It worked. Now, let me just transition really quickly back over into present mode. I've got like 2 more slides that I want to cover with everybody, and then we will. Oh, does that on keep or revert? Keep? Okay, thank you. Okay, just a quick update on the events that we have. In 2 hours, we have a deep dive on this where Adam and David are going to talk a little bit more about architecture. So if you're interested in learning a little bit more about it, please do show up for that. We've got a demo at the Red Hat booth tomorrow at 8:30 a.m. If you want to take a look at that, I believe it's a virtual machine migration from one node to another. And then we've got a KubeVirt gathering this evening. And that location changed. Let me just pull that up really quickly. Aspen Room. Okay, very good. So that's all also going to be posted on the blog post. Aspen Room, 2nd floor of the Sheraton. And then the blog post is listed here if anyone wants to take a look at that and get an idea of all the events. So now getting started, back on the website, on the home page of the website, you've got like 4 buttons. You can get started on AWS or GCP. You provide your credentials. We actually roll KubeVirt VMs and publish them on every update. So you'll be using the latest code. Launch those into your Amazon or GCP account, and you can run through the same demo. You can also deploy it on Minikube, which is listed there, as well as on bare metal clusters. Fabian Deutsch, who's not here, has also created a Katacoda demo, which is 0 barrier to entry. The link is on the slides. And you can basically do the same demo that we just went through here on your browser. And then finally, the KubeVirt demo that gets updated on every release is also on the KubeVirt GitHub page. And then for collaborating, we do have the website, the GitHub page. You can open issues against KubeVirt there if you start testing it out and have any problems. We have a mailing list, KubeVirt-dev. It's a Google group mailing list. IRC, as well as Slack. So please do join the project and start interacting with that. Now, having said that, the rest of the session is going to be, it's actually not that many minutes, for Q&A. Quick question. Go ahead. The question was, if you're using a QCOW2 image, can you pass in cloud init data? And if you are doing that, do you configure it in your YAML file? The answer is yes to both. You can pass in cloud init data, and you do configure that in the YAML file. That was actually shown in the example config that I had. We passed in a password that way. Yep. Next question. Go ahead. That I don't know. Is Steve here? Steve Gordon by chance? Sorry, Steve. The question was, how close to production do we think this is? So he said, you tell us. So we need feedback. We need people to use it. Do we support upgrades from one version to the next? I don't.
Switching to operators in the future, we're hoping for that.
Yeah. So Steve said basically, like we're pivoting to operators, which basically provide a way to extend Kubernetes and provide lifecycle management. So it will be once that pivot is made. You, sir? The question was, does it support multiple networking interfaces? The answer is yes. It does support the Multus plugin, and you can take a look at KubeVirt.io in the documentation, and there's an example on how to set that up as well. You, sir?
More explicit about storage. store VM images in SAP, move that from there.
Yeah, so basically we're designed to be agnostic to the underlying storage. So the assumption is that whatever storage you have configured in your cluster that you can provision PVCs with, you can use to back a virtual machine disk.
Joe, do you mind? Did you see who? Okay. Raise your hand if you asked a question. Joe's got some T-shirts that he's going to hand out. And do we have any other questions while we've got the crew here? Go ahead.
So what we actually use for that mode is it's a separate container. Oh, the question is how does the container disk mode that we've seen here work? Is it just dumping the file system from the container image into the VM? The way that this works is we actually have a separate container that runs in the pod that specifies that container image, and then we're able to point the pod that's actually, or the container that's actually running the virtual machine over to that file system as it's expanded in the other container.
Okay, I'm sorry, folks. It sounds like we're over and we need to let the next presenter start preparing. Thank you, everyone, for joining.